today we're going to continue our discussion of radicals, and we're going to talk about dividing. Now, if I gave you this problem, square root of 5, and I asked you what the index is, what would you tell me?
Square root.
2. Good job. Now, what if I gave you this one?
Cube.
What's the index? 3. Okay, now, I'm going to ask you a couple questions here. If you saw this problem right here, and you wanted to simplify it, could you simplify it?
No.
No, it's done, unless you went and put a decimal down, but we don't want to do that. What would you need to multiply this by in order to eliminate the radical? What do you need?
Another 5.
Another square root of 5, right? Because what's the square root of 5 times the square root of 5?
25.
It's the square root of 25, which is 5, right?
Mm-hmm.
Okay, if I gave you this problem and you said the index is 3, what do I need to multiply this by in order to get rid of the cube root? What's missing? What do I need? How many 5s do I need to take them out of the radical? 3. How many do I have?
4.
So are you in agreement that we need 2 more?
Yeah.
Okay, this is what we need. These are the needs. The needs column. Okay, now what about something like this? What do I need to get rid of this radical? 1 more 5. Thank you, Caitlin. Does everybody see that? Why do I only need 1 more 5? Because this 25 is really what? 5 times 5. Now, what do these result in? They all result in 5. So let's say I gave you the 4th root of 8x squared y cubed. Now I'm going to mix some variables in here. What do I need? What's missing to eliminate the radical? This is what's missing. What do I need? Okay, the indexes have to be the same. So what's missing? Do you need to break 8 up? Maybe some of you need to break this up. 8 is 2, 2, 2.
So you need another 2.
X squared is xx, and y cubed is y, 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 y. So what is missing? I'm sorry. Ah, y. 3 y's, 2 x's, and 3 2's. So how many of a kind am I looking for?
4.
4. So what's missing?
1, 2.
1, 2,
2 x's.
2 x's,
And 1 y.
and 1 y. So if I were to multiply these two, what do I get? What do I get? If I were to multiply this and this, what do I have? I have a 2, and I have 2 x's here and a y. I have a set of 2's, I have a set of x's, and I have a set of y's. So what do I have, everyone?
2xy.
Very good, 2xy. Now, why do you need to know this concept? Well, because today what we're going to do is we're going to talk about dividing radicals. In life, some things are not proper. It's not proper to come to school in your pajamas, right? It's not proper. Can you come to school in your pajamas?
Absolutely.
I guess you can.
Okay, is that a hat?
It's dress code violation, but it's not proper. It's not proper. If you were to go to a black tie event and you were all dressed up in a nice suit, a tuxedo, and the girls are dressed in a long evening gown, would you wear tennis shoes
No,
with what you have on?
no,
Can you? Yeah, you can. Is it proper?
no.
No. Well, in math, you can have a fraction with a radical in it. Is it proper? No. We have to get rid of any radical in the denominator. So I gave you those two analogies so you understand. It's in math, it's not proper to have a radical in the denominator. So what you have to do, it's this fancy word called rationalize. You've got to do whatever it takes to get rid of any radical in the denominator.
Don't you multiply the top and bottom by the same number?
Yes, yes. Now, why do you multiply the top and the bottom by the same number?
To get rid of
What is the same, why can't I multiply the bottom by square root of 5 and not do it the top? What's the reason why? So everyone looks at number 7,
Not like that.
and
Please excuse this interruption. At this time, all seniors who did not attend Crusader Day or do not have an ID card should now go to the cafeteria, or anyone, a senior who is newly enrolled and needs an ID should now go to the cafeteria. This is the final call for anyone who wants to attend Makeup Picture Day in the cafeteria. Thank you.
okay, so we look at a problem such as this, and we say, okay, it's not proper to have a radical in the bottom. So we say, okay, this is what we need to get rid of it. We just talked about what's necessary to get something out, the radical out. But is it fair that you do multiply just the bottom by square root of 5?
No.
Now, you said you multiply the top by that also, but what's the reason? What's the reasoning to do both the same number, the top and the bottom? Does anyone know why these two have to be identical?
So you did an even denominator?
Okay, but what is this equivalent to?
1.
1. Anything over itself is 1. And we learned way back that when you multiply any number times 1, what do you get? Itself. So in other words, we're not changing the value of this fraction. It's still 3 over root 5. So it's very important that there's actually more than 3 concepts here. You need to understand what it takes to get rid of a radical in the denominator. You have to understand that you're going to multiply both the top and the bottom by that same number because that's a 1, and it's not changing the value. And then you have to understand when you're multiplying fractions, what's the rule? You multiply, what's this? Across. What's 3 times the square root of 5? 3 root 5. And what is root 5 times root 5? It's 1 single 5. Is there a radical in the denominator? No. Now, question for you, can I cancel these 2 out?
No.
Why not? It's a 5 and a 5. Can I?
One of them's a root 5 and root 5.
Good job. Good job. Does everyone recognize that this is under a radical, and this is not? If they were both under a radical or both outside, then you could do that, okay? So let's try another one. Number 8. This is number 8. Parenthesis there. All right, what do I need to multiply the top and the bottom by? Square root of 6. Excellent. Okay, so what is the top going to give you? 2 root 6
Over 6.
over 6. Now, is there anything we can do with this fraction? Yes, you can reduce. 2 goes into 6 how many times? 3 times. So what's my answer?
3 root 6.
Do I have to have the 1 here?
No.
No, but if it makes you feel better, put it in. I'm not going to mark you off. Okay, another scenario. Check out this one. I could multiply the top and the bottom by what?
18.
Root 18x. I could. Do I have to? No. I could break this up. What is root 18x equivalent to? If you were to break this up, 9 and 2, and what's 9? 3, 3. So in other words, 18x is equivalent to 2 3s, and an x. Does everyone understand that? 18 is 2 3s, and an x. And I'm going to just put root 7 up here. Now, you can, when you're dividing, and the indexes are the same, if I had something here, like if I had a root 7 here, I could cross them out. You can do that. As long as the indexes are the same, you can do that. You can't do it if the indexes are different. If they're different, there's something else I'm going to teach you what to do if the indexes are different. So for example, if I gave you the cube root of x over the 4th root of x, it would be nice if we could cancel these out.
You just turn
But
the
you
fraction,
can't.
right?
Yes, good job. You turn this into x to the what power?
1/3.
Good.
Next to the 1/4.
I'm impressed. And then what rule did you learn? I know you learned this. If bases are the same and you're dividing, what do you do with these two
You
exponents?
subtract them.
Good. So what would you have to get? A common?
Denominator.
Mm-hmm. Which is what? 12. So this is 4 12s minus 3 12s, which is 1 12. Which, how can you rewrite this? The 12th root of x to the 1st power. So that's what you end up doing. And you're not going to practice any of these. But if the indexes are different and the bases are the same, you have to convert it to a rational exponent and subtract the exponents. You're not going to be doing this today. All of your indexes are going to be the same today, okay? So, with that in mind, back to this problem, let's go back to what we were doing. We took 18 and broke it up into 2 times 3 times 3 times x. Is there anything that can come out, since the index is a 2,
2/3.
yep, you could take these 3's out. Now, what's the reason for taking them out? What are we doing? We are, starts with an S, we are simplifying. We're simplifying this problem. So instead of multiplying the top and the bottom by root 18x,
So would you get the same thing if you did do that?
yes, yes you would. Yes you would. Excellent question. Would you get the same, if I would have gone the route root 18x? Yes, you're going to get the same answer. We're all going to end up at the same spot. So whether you want to multiply both by the top and the bottom by root 18x, fine. If you want to simplify first and see if you can take something out, good. But what would I multiply the top and the bottom by in this problem? A root 2x. So can you give me the final answer? What is it? Louder? Root what in the numerator?
14x,
14x over
3, 4x squared.
3, 4x squared. How about something different?
3.
A 3 for sure.
X.
6x.
6x.
Where'd you get 6x from?
Because this 3 is already out.
The 2 comes together.
The 2 2's come out. This is really root 4. So you take a 2 out. 3 times 2
Oh,
is
okay,
6.
so it is 1, right?
All right? So far okay?
Yeah.
Okay, next. Check out this example, problem 4. Question. What is the index on both of these, numerator and denominator?
2.
They're both 2. Can I simplify this? Is it possible that I just do this?
You can just divide it by 2.
Yes. Anything else we can do?
Yeah, you can divide that x out and then you get
Okay.
x squared.
So in other words, we have the right, because the indexes are the same, I can umbrella this all into a square root of 2, and I can simplify, just like a regular if you didn't see this radical here, and you saw this problem, 50x, if you saw this, 50x to the 6th over 2x to the 4th, and this is why we did that chapter 6 assignment, we reviewed all this stuff. The very first assignment we did. How can you simplify this problem? 25, and then these cancel with 4 of these, and this is gonna become x squared. So what do we really have here? 25x squared. Now can you simplify this? 5x. Got it? Okay, one more example, go to the back. Okay, show me, impress me with your ability to do this problem. And then I'm gonna let you guys work on the homework. Okay, so what is this, are the indexes the same?
Yes.
Yes. Is there anything I can cancel? I have a 7, an x on top, and a 5, and 2 y's. Is there anything?
No.
Unfortunately, there's nothing to cancel. So now I'm left with rationalizing. Why do I have to rationalize? Because it's not proper to have a radical in the denominator. So if I stretch this problem out, I'm stretching it out for you, 5, and then we have 2 y's. Remember that in the beginning I asked you, what do I need in order to get 3 of a kind down here? What's missing? I need another y, I agree.
And you need 2 more 5s.
We need 2 more 5s. Why do I need 2 more 5s, Caitlin?
Because the index is 3.
Because the index is 3 and I only have 1, so I'm missing 2 more. So this is what I need. So what do I have to do to the top?
The same thing.
The same thing. These two have to match. Why? Because it has to be 1. All right, now let's put it together. What do you end up having at the top? I'll give you a hint. Cube root.
25 times 7.
What's 25 times 7?
174.
175.
What else?
X,
X,
Y.
Beautiful. And then what do you have on the bottom?
25 times.
125. Y to the 3rd.
What do we have? What was the whole goal here?
Oh, you take out the 2
You got 3 5s. So the 5 comes out, and what else comes out? The y. Now, what was our goal? Our goal was to get rid of the radical in the bottom. Did we do that?
Yes.
We absolutely did. Can I cancel these 2 y's out?
No.
Can I divide 5 into 175? Why not? What's the reason?
It's under a square.
It has a radical over it.
Very good. So these are not like terms. So what are you going to do for the next 25 minutes?
There's homework.
Oh,
Okay, you're going to make sure, you're going to go back to page, if you had any questions on the previous page, this would be an awesome time. You've got 3 of us to help you out. And you're going to do all these problems. You're going to go 8 through 12, and then finish the back. Are you guys okay?
Yeah.
All right, thank you. You need to stop.
Did you already do this?